Hello class, welcome once again to our lecture for today. So this time we are going to solve sample problem number 7, taken from the sample problems from physics. So here's the problem. It was once recorded that a jaguar left skid marks that were 290 meter in length. Assuming that the jaguar skidded to a stop with a constant acceleration of negative 3.9 or negative 3.90 meter per second squared, determine the speed of the jaguar before it began to skid. Okay, so that's our next problem. So again, we start with writing down the givens. So our problem says we have 200 meter. So what is that? This is the skid marks. Okay, so normally, for example, if we have here it is the road, and assuming the car, the jaguar, skidded from this point, say at t, so let this be at t equal to 0. Okay, at this point, so our v sub 0. Okay, so we don't know what is the speed at the time that the jaguar skidded from this point, and it says that assuming that the jaguar skidded to a stop with a constant acceleration of negative 3.90 meter per second squared. Okay, so to a stop, so assuming that it stops at this point, so the marks that is left by the jaguar up to this point at certain time t. Okay, so time, we don't know the time yet. With the final velocity here, so let this be the final velocity v. So naturally, when the car stops running, so the final velocity is equal to 0. Okay, so the given, we have 290 is the displacement, no, from the point where the jaguar tried to perhaps takes the brake and it skidded this mark, skidded or skid marks that is equal to 290 meters. Okay, so the givens are the following. We have S is given this problem, that is 290 meters, and we have here constant acceleration, so this is negative, so it means that the jaguar decelerated at this rate. So acceleration, which is negative 3.90 meter per second squared, and we are asked to determine the speed. So the speed before it began to skid. So before it began to skid, so it means that is the speed at this point. Now if skidding happens, if so this is skidded, skidded. If skidding happens or started at this point, so the question now is, what is the velocity at this point? So this is our reference point at t equal to 0. So our v sub 0, that is the velocity that is we are going to find. So requirement of this problem is the initial velocity. So we need to find what is the initial velocity before the jaguar skidded to stop. So to stop means velocity is equal to 0. So what formula shall we use for this problem? So again, to get familiar with this formula, so we have to write down those formulas. We have velocity at any given instant of time is equal to the initial velocity plus the acceleration times time. And the other formula, S, that is the displacement, equal to the initial velocity times time, then plus 1/2 times the acceleration times the square of the time. And then the third one, so velocity squared equal to initial velocity squared plus 2 times the product of the acceleration and the displacement. Okay, so which of this formula shall we use? So we need to find the initial velocity, or the v sub 0. Okay, so to find the initial velocity, so I think the best formula here that we can use is the third one. Okay, so using the third one, we have velocity squared equal to initial velocity squared plus 2as. Okay, so we make use of this formula. And when Jaguar stop, no? When Jaguar stop, so when the Jaguar stops, so we have the velocity at that instant is equal to 0. Okay, so substituting, we have 0 equal to initial velocity squared plus 2 times, so what's the acceleration? So we're given the acceleration, that is negative 3.90. So we'll just omit for a while the units. So 0 is equal to v sub 0 squared minus, so what is the product of this? Okay, so this is negative, no? This becomes negative, so 2 times minus 3.90, and we have S. What is S? Sorry, I forget to write the S here. S is equal to 290. Alright, so 290. Okay, so transposing this part. So when you transpose this part to the left side, or you just transpose this to the left side, so whichever class, so that's just the same. So this will become positive. So we have positive, this, the product of this, okay, and then you have positive VO squared, or we can write this as VO squared equal to, so this becomes positive, so this becomes 2 times 3.90 times 290. Okay, then solving for the initial velocity v, so we take square root on both sides. So taking square root on both sides, so we have the initial velocity equal to the square root of 2 times 3.90 times 290. So using your calculator, So we have the result of this, then take the square root, and we'll get 47.56 meter per second. Okay, so this is the answer for this problem. Any question? Right, so we have here the acceleration negative, so it means the car, the Jaguar, decelerated. It slows down. So that's why we have here the acceleration, the rate of change of the rate of change of velocity with respect to time, but it's slowing down. So that's why we have here a negative. Okay, so thank you very much, and see you again on our last example, our example number 8, in our next video. So bye.